Right, so there's a tool within QDM 3D Analyst here that is our tolerance negotiation tool. It's a rather new tool, so even if you're a QDM user, it may be new to you as well. What this table is going to do is it's going to identify the name of the point, the page. The first few boxes here are current specifications. So these are the results from the model, including the spec limits, tolerance band, CP, CPK. So we can see the CP, CPK. We have some color coding here and yes, no explanation. So what the system is telling me within this table right now is based off a CP, PP target at the bottom. I have it set at 1.67. I can even make it 1.33. If I hit recalculate, what the system's going to do here is 1.33, could even do a nominal based 1.67. So we have a few options. I'll make it even easier. I'll just reduce the amount of points on here so there's not so many. So we'll do this. To keep selected. Oh, it's not working as planned. Yeah, so I just picked a few of these features. I'll just highlight them here, make it easier. We can see with the 1.67 target, what it did is we can see the changed of yes or no. We've changed some of these that I had selected to the 1.67. So I have a point here. The new specification is a minus 0.78 tolerance plus 2.38, and that's because right now I have it at nominal based. Our nominal based gap was 0.8. I'm going to go ahead and make that one deviation. Yeah, we could do deviate. So we have the option to do deviation based or nominal based. Since my nominal is the 0.8, that's why we're seeing some kind of skewed numbers a little bit, but so we do have the option CP, CPK, PP, PPK, deviation, nominal based, and you can play with the different targets, recalculate. We can also type in different spec limits. So if a supplier in this case called and said, or is working with the OEM, you can type in a limit here. If I just wanted to go 2.25, now we can see we've created a 1.82 CP, or you can even reduce the lower tolerance to be 0. What is that going to produce? So it's a little bit of plug and chug involved if you'd like to kind of look for certain numbers.
So this lets you know which tolerances, which features in your model with their set designs are going to meet the desired target, and if it's not going to meet the desired target, what it would need to be changed to in order to meet that target. And then with the ability to update on the fly, you can actually use this as a live tool during your talk with your client and show them, all right, well, if you want to change the upper or lower spec limit to 2.25 or change the lower spec limit to 0, here's what our end result's going to be, and it'll calculate it right on the fly. So it's a really nice tool to have open during your meetings so you can show, here's going to be our estimated output. Here's going to be what we can expect. Here's going to be where we're going to have risk factors. It's a nice way to use data to back up what it is you're trying to say. So that way, your customer really can't argue with the numbers.
So we can also change like the nominal. I could put in a different number here to apply like a mean shift. What would happen if we did a small mean shift and a new CP, CPK, tweaking the spec limits, tweaking the nominal. So it's open for you to play with the numbers, and we also have an export option where you can export this to Excel and take a look at some of those numbers, share the chart with colleagues or customers, OEM suppliers. So that's with the outputs from 3DCS. I'm going to go ahead and open a piece part here real quick. So that was with the 3DCS output. So what we have right here is, let me just get into this, is we have 25 samples have been checked in the plant floor. So what we can do with the 25 samples that we've already inspected, we can use that tolerance negotiation tool kind of in the same manner. With typing in the spec limits, using the target, recalculating. As we can see here at the bottom, I have points that they've changed the CP to 1.67 with the actual measurement data. So you can start to get an idea what tolerance was needed to meet the goal. So that's with the plant data.